This is part 2 of writing, solving, and graphing inequalities. What I'd like you to do is copy down these 3 inequalities, solve them, and graph them. And then when you have finished, go ahead and hit play and we will go over the answers. Alright, the solution for the first one is negative 1 2/3. A is less than negative 1 2/3. So you're going to have an open circle at the negative 1 2/3 with an arrow pointing to the left. In order to solve for this inequality, you're going to use the inverse operation for this problem, which would be multiplication. And we will use the multiplicative inverse here of 8/3. And just like equations, whatever you do to one side of an inequality, you must do to the other side as well. So we'll have to multiply both sides by 8/3. When we simplify, we'll be left simply with a on the left-hand side, and on the right-hand side we'll be left with negative 5/3. We'll have an open circle at the negative 5/3, or as a mixed number, negative 1 2/3, pointing to the left. It's always important to check your solution. So I'm going to replace a with a value that is less than negative 1 2/3. And I like to make it simple, so I'm going to select negative 8/3. That'll give me negative 1, and that statement is true. Negative 1 is less than negative 5/8. Here's the solution for the second one. You're going to have a closed circle at negative 16.5 pointing to the right. In order to solve for this equation, or this inequality, we're going to have to use the inverse operation of addition. But first I'm going to use the commutative property to rewrite my inequality, to get my variable all the way to the left. Is this a requirement? No, but it makes it a little bit easier as far as management of the problem goes. So using the inverse operation of addition and subtraction, I'm going to subtract 3.3 from both sides. That'll give me a solution of y is greater than or equal to negative 16.5. Graphing this solution, I'm going to use a closed circle at negative 16.5, and it's going to be pointing to the right. Here I'll go ahead and pick a number that is greater than negative 16.5 to check my solution. And just to make it easy, I'm going to select 0, because that is greater than negative 16.5. So when I replace the variable with 0, 3.3 is greater than negative 13.2. Here's the solution to the last problem. Negative 2 1/4 is, well, the variable is greater than negative 2 1/4. How I go about solving this, I need to use, this is a two-step equation for inequality. So the first thing I need to do is do the inverse of subtraction, and then the second thing I'll have to do is use the inverse of multiplication, which is division. So first step, I'm going to add 1 1/2 to both sides. That'll give me negative 2x is less than 4 1/2. And the next step, I'm going to multiply by negative 1 1/2 on both sides of the inequality. On the left side, that will give me x, and on the right side, that will give me negative 9/4 or negative 2 1/4. Now, when I replace my inequality, initially when I graph it, it looks like this, but when I replace my inequality, my variable with a value, so here I have negative 3, you'll notice that the solution is incorrect. 4 1/2 is in fact not greater than or less than 3. It's actually greater than. And that's the takeaway from this lesson. If you multiply or divide by a negative number, then the inequality symbol gets flipped. So you'll need to flip the inequality sign anytime you multiply or divide by a negative number. And of course that will get your graph pointing in the other direction.